3, 2, 1.
America was not built only with steel, concrete, and glass. It was built from moments that seemed impossible to overcome: economic collapse, national loss, burning deserts, the frozen wilderness of Alaska, endless stretches of water, and even the dream of reaching beyond Earth. Some of these projects were once seen as too insane, too early, too expensive, or too dangerous to become real. And yet, they rose, as towers piercing the clouds, bridges disappearing into fog, dams holding back the force of rivers, giant spillways swallowing the water down into the reservoir, like a doorway opening into the earth. In today's journey, we will step inside the megaprojects that force the world to look at America in a different way. A place where ambition no longer remained on paper, but became massive symbols standing in the real world. NASA Vehicle Assembly Building. At Kennedy Space Center in Florida, the Vehicle Assembly Building was created for machines too large to be assembled like ordinary aircraft. Built during the Apollo era, it was designed to stack the Saturn V rocket, the vehicle that would carry astronauts toward the moon. The building rises 525 feet, with a vast interior where rocket stages could be lifted, aligned, and prepared before rolling out toward the launch pad. Its scale is difficult to understand from the ground. The American flag painted on the outside is so large that each stripe is wide enough to cover a roadway. Inside, the space is open and vertical, made for rockets that had to stand upright long before they ever touched the sky. Decades after Apollo, the building still remains part of America's space program. It has been used for the space shuttle, and today, it supports the Artemis program as NASA prepares a new generation of missions beyond low Earth orbit. Inside this giant structure, spaceflight begins quietly, not with fire, but with assembly. Starship. In South Texas, SpaceX is building a rocket system that looks less like a single spacecraft and more like an entire launch architecture for the future. Starship stands nearly 400 feet tall when stacked with its super-heavy booster. It is designed to be fully reusable, with the goal of sending large payloads, satellites, cargo, and eventually people far beyond low Earth orbit. What makes it different is the way it tries to change the economics of spaceflight. Instead of treating rockets as machines, used once and thrown away, Starship is built around the idea of flying, landing, and flying again. Its stainless steel body gives it a bright, almost industrial appearance, unlike the white rockets that defined earlier space programs. At the launch site, the giant tower known as Mechazilla is designed to catch the returning booster with mechanical arms, reducing the need for landing legs and speeding up reuse. From the outside, Starship looks simple, a silver rocket standing near the coast. But inside that shape is one of the most ambitious attempts to make space travel more frequent, more powerful, and far less distant from everyday human imagination. Lake Pontchartrain Causeway. In Louisiana, the Lake Pontchartrain Causeway does something that feels almost impossible from the driver's seat. It carries traffic so far across open water that, for a moment, land seems to disappear in every direction. Stretching about 23.6 miles across Lake Pontchartrain, the bridge connects the New Orleans area with communities on the North Shore. It was built to turn a long trip around the lake into a direct crossing, saving time and changing the daily movement of people across the region. What makes the causeway so unusual is its emptiness. There are no mountains, no skyline, no dramatic cliffs beside it. Only water, sky, and a thin line of road running toward the horizon. In the middle, the view can feel almost disorienting, as if the bridge is floating between two worlds. Even today, crossing the causeway can feel strangely quiet, with only the road ahead, the lake below, and the horizon slowly pulling the drive forward. Hoover Dam. On the border of Nevada and Arizona, a wall of concrete rises from the Black Canyon and holds back one of the most important rivers in the American West. Built across the Colorado River during the Great Depression, this dam was not just an engineering project. It was a response to water, power, flood control, and the future growth of the desert Southwest. At 725 feet high, it turned a wild river into a controlled source of electricity and created Lake Mead behind it. What makes the structure so powerful is the contrast around it. On one side, dry cliffs and desert heat. On the other, a massive reservoir that helped cities, farms, and industries grow in places where water could never be taken for granted. Its turbines can generate roughly 2,000 megawatts of power, enough to make the dam more than a monument. It became a working machine at the heart of the region. Marina Bay Sands rises from reclaimed land along Singapore's waterfront, where three slender towers lift a long sky park nearly 650 feet above the city. From a distance, the complex looks like a massive ship resting across the rooftops. But behind that simple image is a difficult engineering problem. The towers must carry a structure with gardens, restaurants, observation spaces, and an infinity pool longer than a football field. That pool holds thousands of tons of water, while the building still has to allow small movements from wind, heat, and the natural sway of each tower. Inside, Marina Bay Sands works almost like a vertical city, with more than 2,500 hotel rooms, exhibition halls, theaters, retail areas, and a museum shaped like an opening hand beside the bay. Its real power is the way it turns engineering into a skyline image Singapore can be recognized by almost instantly. Morning Glory Spillway. At Lake Berryessa in California, one of America's strangest water structures, looks less like a piece of engineering and more like a hole opening in the surface of the lake. Known as the Morning Glory Spillway, it was built to protect the Monticello Dam when the reservoir rises too high, instead of letting water pass over a normal edge. This design allows excess water to pour into a giant circular opening, then drop through a vertical shaft before being released downstream. What makes it unforgettable is the way it appears when active. Calm lake water suddenly begins to curve inward, forming a massive spinning funnel that seems to pull the surface of the reservoir into the earth. It is beautiful, but also slightly unsettling. This spillway is not built for spectacle. It is a safety system designed to control pressure and prevent dangerous overflow. The Sphere. In Las Vegas, the Sphere does not rise like a traditional tower. It appears almost like an object that landed in the desert, a perfect glowing form covered in moving light. At 367 feet tall and 515 feet wide, it is one of the most unusual entertainment structures ever built. From the outside, its surface becomes a massive digital skin, using around 1 million LED lights to transform the entire building into a planet, an eye, a moon, or a living screen visible from miles away. Inside, the venue was designed to surround the audience with image and sound, instead of placing entertainment in front of them. Nearly 20,000 people can sit inside a space where the screen curves around the body, making the building feel less like an arena and more like a controlled world. In a city already known for spectacle, the Sphere pushes the idea further. Willis Tower. In Chicago, the skyline tells a different story from New York. Here, height was not only about glamour, it was about engineering, structure, and the bold confidence of a city built on industry. Completed in 1973, this tower became the tallest building in the world and held that title for about 25 years. With its antennas, it reaches 1,729 feet, rising above the flat landscape of Illinois like a dark vertical machine. What makes the building powerful is its bundled tube design. Instead of one single tower pushing upward, it is formed from a group of square tubes joined together, each stopping at different heights. That stepped shape gives the building strength against wind while creating one of the most recognizable silhouettes in America. For decades, it stood as the ultimate symbol of Chicago's ambition. Not as flashy as New York's Art Deco towers, and not as emotional as One World Trade Center, but massive, practical, and confident. Transamerica Pyramid. In San Francisco, one building changed the skyline not by looking taller than everything else, but by looking completely different. Its sharp pyramid shape rises from the financial district like a piece of geometry placed among ordinary towers. When it was completed in 1972, many people criticized it. To some, the design felt too strange, too aggressive, and too disconnected from the historic character of the city. But over time, that unusual shape became its greatest strength. The narrow top allows more light to reach the streets below, while the wide base gives the structure a strong presence in a city known for hills, fog, and earthquakes. At 853 feet, it remained San Francisco's tallest building for decades, until a new generation of towers finally passed it. What makes it memorable is the contrast. New York's skyscrapers often feel dense and vertical. Chicago's feel muscular and engineered. But this one feels almost symbolic. A modern pyramid rising through Pacific fog, turning a business tower into one of the clearest visual signatures of San Francisco. Billionaire's Row. Along the southern edge of Central Park, a new kind of skyline has risen. Thinner, taller, and more extreme than almost anything New York built before. Billionaire's Row is not one single building. It is a cluster of super-tall residential towers, designed for a world where height is no longer only about offices, power, or public identity. Here, height becomes private luxury. Apartments rise hundreds of feet above Manhattan, with views stretching across Central Park like a living map of the city. What makes these towers unusual is their shape. Many are extremely slender, forcing engineers to solve one of the hardest problems in tall building design: wind. At that height, even a luxury tower must behave like a tuned instrument, using strong cores, dampers, and careful structural balance to reduce motion. Central Park Tower became one of the most striking examples, rising to 1,550 feet and turning residential space into vertical territory. From the street, these towers can look almost unreal, narrow lines of glass reaching into the sky. Golden Gate Bridge. At the entrance to San Francisco Bay, the Golden Gate Bridge stretches through fog, wind, and open water, like one of America's most recognizable lines of steel. When it opened in 1937, it was the longest suspension bridge main span in the world. Its central span reaches 4,200 feet, crossing a channel that had long challenged engineers with deep water, strong tides, heavy fog, and powerful coastal winds. But what made the bridge unforgettable was not only its engineering, it was also its appearance. The orange color, originally connected to protective primer, became part of the bridge's identity because it stood out so clearly against gray fog, blue water, and the rugged hills around the bay. For San Francisco, this bridge did more than connect the city to Marin County. It changed how people imagined the edge of the American West. It became a gateway, a landmark, and a symbol of crossing into something larger. More than a way across the bay, it became the image people remember when they think of San Francisco, a gateway between the city, the ocean, and the open promise of the West. Burj Khalifa does not simply rise above Dubai. It changes the way the desert city is measured. At 2,717 feet, it remains the tallest building ever constructed, turning the skyline into a vertical marker, visible from miles away. Its stepped, tapering form is not just for appearance, because each setback helps disturb the wind as it moves around the tower, reducing the forces that become more dangerous at extreme height. Inside, the building works like a city stacked upward, with residences, offices, hotel spaces, restaurants, and observation decks spread through more than 160 floors. Reaching that height also demanded unusual construction solutions, including concrete mixtures that could be pumped higher than builders had ever attempted before, along with elevator systems designed for some of the longest vertical journeys on Earth. Burj Khalifa matters because it made height feel less like a number and more like Dubai's clearest statement of what it wanted the world to see. Hudson Yards. On Manhattan's west side, Hudson Yards shows a different kind of American megaproject. Not a single tower, but an entire district built above active rail lines. For decades, this area was defined by train yards, industrial space, and land that felt separated from the main energy of Midtown. Then the city began turning that space into one of the largest private real estate developments in the United States. What makes Hudson Yards unusual is what lies beneath it. Much of the district sits on a massive platform built over working rail tracks, allowing trains to continue moving below, while towers, shops, offices, public spaces, and luxury residences rise above. It is almost like a city built on a second ground level. At the center of the development is the vessel, a honeycomb-like structure made of stairways, landings, and reflective metal. Around it, glass towers reshape the western skyline and pull Manhattan toward the Hudson River. Hudson Yards is not only about height, it is about transformation, taking a piece of hidden infrastructure and turning it into a new vertical neighborhood. In a city where land is limited, the future is sometimes built directly above the past. Trans-Alaska Pipeline. Across Alaska, The Trans-Alaska Pipeline cuts through one of the most remote and difficult landscapes in North America. Stretching more than 800 miles, it carries oil from Prudhoe Bay on the Arctic coast to the port of Valdez in southern Alaska. Along the way, it crosses mountains, forests, rivers, tundra, permafrost, and active earthquake zones, places where ordinary construction would not survive for long. What makes the pipeline unusual is how much of it stands above the ground. In many sections, it is lifted on supports to protect the frozen soil beneath it. If warm oil melted the permafrost, the ground could shift, sink, or break the structure apart. The pipeline also had to be flexible. In earthquake-prone areas, it was designed to move slightly instead of cracking under pressure. In the cold, it became a long metal line built to survive temperature, distance, and isolation. From the air, it looks like a thin silver thread running through wild Alaska, connecting the frozen north to the open sea.
Along the rugged coast of Maine, Acadia National Park greets the first light of America each morning. Granite cliffs rise above the Atlantic, shaped by glaciers and endless tides. Waves strike rock with patient rhythm, carving shoreline across centuries. Pine forests cling to mountainsides while sea fog drifts between earth and sky. Acadia feels intimate despite its vastness, a place where sunrise becomes ceremony. Hikers gather quietly atop Cadillac Mountain, waiting for light to reveal ocean and island horizons. Here, reflection comes naturally, encouraged by solitude and open space. The meeting of land and sea mirrors the meeting of past and future, stillness and change. As morning light spreads across the coast, Acadia reminds us that beginnings happen daily, offered freely to anyone willing to pause and watch.